Hi guys, welcome to our first lesson in chemistry. We are going to be having an introduction to chemistry. What is chemistry? I mean, what comes to your mind whenever you see or hear the word chemistry? I've heard many people believe that chemistry is the study of chemicals. And while that is true, it is not entirely correct. You see, when we say chemistry studies chemicals, we limit our minds because chemistry studies all the substances around us. It helps us understand their particulate nature and how they interact with each other and energy and what we can do to them. In other words, chemistry is the science that is concerned with the study of matter, its properties, how and why substances combine to form other substances, and how these substances interact with energy. It is the comprehensive study of matter. How can we confirm that this is pure water? It's odorless, it's colorless, it has no taste, and it boils at 100 degrees Celsius. Everything we have done is chemistry. We know water is colorless, odorless, tasteless, and boils at 100 degrees Celsius because it was proven before and we have read about it in books or our teachers have told us the fact before. Furthermore, we know that what was in the cup is pure water because we have proven it practically by applying these theories. We view chemistry from multiple standpoints, theoretical and practical, because both need each other to provide a clear picture of matter. Chemistry is so broad that it is used in every aspect of life. We use chemistry in food production, clothing, in the military, medicine, housing, and transportation. Therefore, we make use of products of chemistry on a day-to-day basis. Measurements of physical quantities. Oh, I know we have to look at the means of measuring physical quantities, but before I go into that, let me tell you what physical quantity is. The physical quantity is the property of an object that can be quantified, that is, that can be measured or counted. For example, the length of a rod or the mass of a body. If I need 20 grams of sugar to make my cake sweet, that physical quantity of 20 grams can only be gotten by measuring it out of this bag. Measurement is defined as the act of comparing a physical quantity to a standard unit. For instance, when I measured the length of my working table just now, it was in inches. I didn't decide what length is equal to an inch. It is already a standard measurement. Because it is standard at every point in time regardless of who measures it, 5 inches in Nigeria is equal to 5 inches anywhere else in the world. Knowing the measurements of units in chemistry is of utmost importance. Today, the generally accepted system of units is the International System of Units, also known as the SI unit. The SI unit specifies a set of 7 base units from which all other units of measurement are gotten. It is a group of the foundation standard measurement for every entity. Length, meter. Mass, kilogram. Time, second. Electric current, ampere. Thermodynamics temperature, Kelvin. Amount of substance, mole. Luminous intensity, candela. Discoveries are an integral part of science. We only know what we know today because scientists discovered them. Scientists by nature are curious and wonder about many things. Therefore, to ensure that what we teach, learn, and accept as fact is true, every idea has to undergo what we call the scientific methods. We form laws and theories by this process, and it involves A. Observation. Through observation, they see a pattern which leads to a problem they try to solve. They can either be quantitative or qualitative. B. Hypothesis. After observation, scientists put forward a solution explanation by investigating the problem and put forward the solutions. C. Experimentation. After probable hypothesis is formed, experiments are conducted to test the validity of the hypothesis. D. Formulation of laws and theories. When results from experiments are established, it is tested to know if it is correct without the limit of available evidence. A theory is established if the results conform to available evidence. A law of principle is established only after the theory has been extensively tested and proven true. without any exception. Let us use this as an example. For instance, if I discover that girls are different from boys in this class, and I want to document the fact or establish it in science, first, I'll have to observe closely if the girls really differ from the boys, or if it was a figment of my imagination. I'll also find out what exactly the difference is, and then maybe I realize that girls have longer hair than boys. It's a quantitative difference. Next, I will formulate my hypothesis, which is an answer to my scientific question. So, my hypothesis will be, in this class, all the girls have longer hair than boys. This hypothesis is what my experiment will prove. My experiment will be measuring everybody's hair. After measuring everybody's hair in the chemistry class and comparing, I'll get my results. My theory could be, in this chemistry class, all the girls have longer hair than boys do. This theory can only become a law if I keep proving everywhere that girls' hairs are always longer than that of boys in chemistry class, and there is no exception. That is how we use scientific methods to make discoveries. See you in the next lesson.